Solving linear systems with three equations and three variables in which some of the equations have missing terms. So say I'm given 3x minus z equals negative 10, 4y plus 5z equals 24, and x minus 6y equals 8. So let's say we took this equation out. So we have 4y plus 5z equals 24, just rewriting it. And we want to make it so that the other equations have eliminated x. So to eliminate x out of the other two equations, I'm going to multiply the bottom equation by negative 3. So my bottom equation becomes negative 3x plus 18y equals negative 24, leaving the top equation the same. This is what I get. Adding the two together, cancel. 18y and negative z don't add together. Negative 24 and negative 10 make negative 34. So now we have these two equations. So I'm going to write these next to each other. Notice that if we multiply this equation, this should have been a positive 24. So this should have been a positive 14. So once again, checking your math really quickly will save a lot of headache later, because you don't want to miss a positive or negative on these big equations. So notice positive 5z, negative 1, this would be easy to become a 5. So let's make it a 5 so that the z's will cancel. So leaving the top equation the same, times in the bottom equation by 5, 18 times by 5 is 90y, negative 5z equals positive 70. So I get 94y equals 94, because these cancel. So y equals 1. Back substituting, just like we learned on the last example, into either one of these originals, I'll just do the top. So 4 times 1, because y, plus 5z equals 24. 4 plus 5z equals 24. 5z equals 20 by subtracting 4 from each side. Dividing by 5, and z equals 4. So I have two pieces out of the three. To get the third, I just have to back substitute again into any one of the equations that has an x. Let's just do the bottom. So x minus 6 times y, well, y is 1, equals 8. X minus 6 equals 8, add 6. X equals 14. So the solution set of 14, 1, 4 is where these cross. So we want to go back through and just double check our math, since these problems are really easy to misplace a negative. And I actually want to even double check myself. I'm human and I make mistakes. So we have 3x minus z equals negative 10, 4x plus 5z equals 24, x minus 6y equals 8. So we said we're going to keep this one the same. Multiply this bottom one by negative 3. So down here, that's what these are. So I get negative 3x plus 18y, negative 24. Oops, that should have been a negative 8. There we go. Negative 8, negative 8, adding over, we get negative 2. See, there's our negative. So this would be our solution set. So really important to check yourself. One way you could see if this is really a true statement by the time you get here, rather than having to comb through and comb through and comb through for negatives, because I'm prone to do this too, is to make mistakes with negatives. The thing to do is if you can stick this point into all three equations and get a true statement in all three, it is the solution or a solution to this system of equations.